Yes, Mr. Samir, over to you.
Good morning, everyone. I hope you can hear me.
Yes, yeah.
Yeah.
Okay.
So, yeah, before we get started, let us have some basic introduction from each other, or else to keep this short, can I have, I think chat is enabled, right? People can chat, isn't it? Faisal, can somebody chat? Okay, yeah, I can see somebody. Yeah. So, what we can do is, can we have the location from where you're joining, please? Like, let's say Dubai, India, or let's say Hyderabad, from where I come from India. So, can we have that, please? So, let's get that going. Okay, so I have people coming from Dubai, Sharjah, Abu Dhabi, from Hyderabad, Saudi. Very good. So, so that seems that obviously UAE MEP engineers is not only limited to UAE. I can see people have joined from UAE, Saudi, India, Turkey as well, which is good to see the diversity among the audience. So again, thank you to UAE MEP engineers community for inviting me to share my knowledge, my experience with the community as well. So let us keep this workshop very interactive, very engaging. If you have any questions, please feel free to ask. You can stop me, you can raise your hand, you can ask questions so that I can clear that topic then and there and we move forward. I hope I'm clear on that. Perfect. So let me share my screen and please let me know if it is what do you call that? If it is visible to you. Just a moment. I hope you can see my screen.
Yes. Okay.
Perfect. Great. So what we do is we start from the basically the topic. Today's topic is about corridor smoke management. So first thing is, why do we need to provide smoke management in the corridor? That's the first question, right? So to understand that concept first, we need to understand that most of the deaths that happen in due to fire happens due to burning. Like obviously when you are in that fire corridor, right? So you tend to escape the corridor, right? So but again, as per the data, we have got to know that the deaths that happen, is it due to fire or is it due to the smoke people inhale as they're evacuating, right? The answer is very clear. The deaths happen not due to burning, mostly it happens due to the smoke inhalation. So it is very, very critical or important, let's say, to remove the smoke from that floor, right? So now, just to give you some more background on today's presentation. So today's presentation will be focusing more on projects or the code which is from UAE, right? So in UAE, we have a code called as UAE-FLS, which will refer to whatever we design when it comes to life safety. So the reference is UAE-FLS code. Yeah. So now, so the point is, coming back to the intent, as a design intent, our job is to remove the smoke from the corridor and keep it free for people to evacuate, right? That's a strategy. Okay. So why do we do this? Is because we need to keep the corridors and the egress path clear of smoke so that people can easily evacuate. That's what we understood. Perfect. Next, apart from people evacuating, we also need to take care of firefighting operations, right? The people who want to, the firemen, as they come and they want to, they have to fight the fire. They need to also have the corridor free for smoke. So this is how it is. We are designing the smoke management, particularly for a corridor. So next question: how do we decide it? How do we decide how much airflow is required? Whether it is 200 liter per second, 300 liter per second, how do we decide that? So it's a very simple strategy to find out the flow rate that has to be taken out from the corridor, which is 6 ACH, right? So what is ACH? ACH is the amount of air. Let's say you have a balloon, right? So if you take out the entire air from the balloon one time in 1 hour, that is 1 ACH, right? So the 6 ACH is you are removing the air completely 6 times in 1 hour. So that is 6 ACH, right? So now the corridor smoke management, the flow rate required for the corridor smoke management should be minimum of 6 ACH. This is for extract, right? So in corridor smoke management, what do? We provide extract air and also we provide makeup air. Extract, again, I have a question. I believe most of the people are mechanical engineers. In case of fire, right? So you have corridor and you have staircase. How do people evacuate? The people who are in the homes, apartments, they will come out of the apartment, they will walk in the corridor or run in the corridor, and they will go to ground floor from the staircase because lifts will all get shut down, right? So as they're taking this route from the home, opening the door of the apartment, going out in the corridor, and again getting into staircase. So this corridor, the entire corridor zone, let's call that as one zone, right? This zone should be in negative pressure or positive pressure. What do you think? Uh, Actually, let's do one thing. Whenever I ask a question, right, I think you can unmute because I'm not able to see the chat here if somebody is typing in the chat. Okay. So what is it? We quickly unmute and give your opinion
Negative
or give
pressure.
your answer. Then we can mute yourself. No problem. Yeah.
Negative pressure.
Negative pressure. So why do we need to maintain negative pressure? Because we don't want this smoke to escape to other rooms or other areas or other zones. Let's say staircase or other floors, right? So you always keep under negative pressure. So as we're extracting 6 ACH, the makeup should be less than the extract. So again, the code says consider 6 ACH for the extract and 85% of that 6 ACH should be makeup. I'll give you the numbers one more time. 6 ACH for the extract flow rate and 85% of that 6 ACH should be your makeup flow rate. Right? Okay, let's move that. Let's do that anyways in the coming slides. So this is what the extract of the code is. This is taken from the UAE FLS code 2018 version, page number 822. If you go to this page, you'll find this particular clause or guideline. Clear? We'll move forward. Okay. So as I said, what is ACH? How many times the total air inside a room is replaced in 1 hour? If it is 10 ACH, you need to do that in 10 times in 1 hour. Clear? Okay. We discussed this. 6 ACH you need to do for the extract. For the makeup, you need to do 84% of that. Now, the question, usually designers, sometimes they get confused in this question. When you're doing extract calculations, let's say in corridor, you will have false ceiling. Right? Let's say you have false ceiling of 700 mm void. So when you're calculating the flow rate, for the flow rate, how do you calculate? We have 6 ACH. And that 6 ACH, how do you do it? You take the area of the corridor into height of the corridor, you get volume into 6 ACH. That's your flow rate, right? So the height of the corridor, what height you should take? You should take to the fall ceiling level or until soffit level. So to answer the question is, you should consider the entire volume, which is until it's soffit of the slab. Now, what is soffit of the slab? Anybody has an idea what is soffit of the slab? No idea. So
Till ceiling.
yeah, basically soffit of the slab is, let's say you're standing on a floor, right? And if you look up, so you'll find the slab, right? You'll find the slab there on your once you look up on the lesson. So that bottom of the slab is the soffit of the slab. Perfect. Next. Yeah, okay, it's here. The image from the FFL. This is FFL. What is FFL? FFL is finished floor level. Okay. Next is software slab. Software slab is what? This level, the bottom of the slab. Clear? Okay. Next. Next is corridor smoke purge system. In smoke extract fans, shall be, obviously it is dealing with smoke, right? As it is dealing with smoke, for sure the smoke temperature will be very high. Obviously, smoke temperature will be very high. That's a different subject. But the extract fans specifications or the rating of the fans should be such that, as per code, it should be 400 degrees for 2 hours. It should be able to withstand 400 degrees for 2 hours. That's the code which says about extract fans. Next, the backup should be provided. The standby is not required for the smoke fans. Whether it is corridor fans or basement fans, whatever fans that is, the code says clearly standby is not required. Perfect. Next, the makeup fans. Again, as we are extracting the smoke from the extract fan, it should be fire rated. How much it should be? It should be 400 degrees for 2 hours. It should sustain. Whereas makeup fan can be fire rated or it cannot be fire rated. Because the makeup fan, we are pushing the fan from the outside to inside, right? So if the fan location is at roof level, which is open to sky, then we don't need to provide fire rating for this fan. Or if the fan is in the fire zone itself, let's say you provided the fan in the basement level. Basement different subject, but I'm telling you just to get an idea, right? So if the fan is in the fire zone, in many cases in basement, you'll have the fan in the fire zone in the basement itself. So that fan should also be fire rated, the makeup fan. Otherwise, corridor fans, mostly they will be located in the roof. As it is in the roof, we don't need to provide fire rating for the makeup fan. But extract fan, 400 degrees, 2 hours is required. Again, this is the code where it says we need to provide the fire rating for the fan, for the extract fan mainly. So this is how the fans will look for, like axial fan and centrifugal fan. Okay. Now, when it comes to emergency power, obviously during fire, the building power might get shut down, right? So in that case, your generator should be able to work and also make these fans work. So that's why fans and related equipment should always be on an emergency power. Okay. Now let's do a question. For a corridor of area 100 square meter, height is 3.2 meters. This height is from soffit of the slab, from the FFL to soffit of the slab. Now tell me how much flow rate of exhaust should be done on this project. Give me both actually, both numbers. Smoke exhaust and makeup air. How much is required in liters per second? Can you do this quickly?
Five 33 liters per second.
How much is that?
Exhaust.
533.
Exhaust. 453 liters per second. Makeup air.
So 533 and 453, right? Two numbers you said.
Yeah.
533 is the exhaust, 453 is the makeup.
Makeup.
So does anybody has any other answer? Actually, I'm not familiar with Google Google Meet. Can we draw something here or no?
Actually, 1920 for the
1920. Okay.
yeah, extract, and 85% 1632.
Okay. Okay. Any other answers? Okay. Now I'll show you some easy, very easy, like within seconds, you can do this actually. I'll just tell you how to do that. I'll give you some shortcuts. First, before I give you the shortcut, let me explain to you about units. 1 meter cube is equal to 1000 liters. Clear? 1 meter cube is equal to 1000 liters. And 1 hour is equal to 60 minutes. I'm not sure whether you know that or not, but that's okay. And 1 minute is equal to 60 seconds. So I hope you learned something new today. So what is asked here is they have asked to consider liters per second, right? So now first thing what I will do, I'll multiply area into height to get volume. So area how much? 100 square meter into height 3.2. So 320 meter cube is my volume. I think everybody has followed so far. Clear? Now this 320 I have to do what? 6 ACH. So that means 320 is what? 320 is volume which is in meter cube. Now I'm multiplying this into ACH. And when I say H means hour, right? Air changes per hour. So 320 into 6. This is meter cube per hour, right? So this meter cube per hour, the question says give the answer in liters per second, right? So this meter cube per hour, we have to convert into liter per second. So how do we do that? Simply divide that answer divided by 3.6. You will get the answer. Okay. So I'll repeat. 1 meter cube per hour is equal to actually meter cube per hour divided by 3.6 is liters per second in simple words, right? So divide meter cube per hour by 3.6, you will get the answer in liter per second. So what I did, I multiplied first, I got the volume by multiplying 100 into 3.2. 320 is my volume, 320 meter cube into 6 ACH 1920. This 1920 is meter cube per hour. Divide this by 3.6, you will get the answer liter per second, which is 533 liter per second for the smoke extract. And for makeup into 0.85, which is 453 liter per second. Is it clear to everyone?
Yes.
Yes.
Perfect. So this is the answer. This is explanation. See, corridor 100 square meter, height 3.2. So exhaust air 100 into 3.2 to 6 meter cube per hour, 1920 meter cube per hour. Now I am converting liter per second. If I divide this by divided by 3.6. Actually, I think this is wrong, right? This should be divided by 3.6, right? Okay. So 533, we get liter per second meter cube per hour divided by 3.6, you will get 533. Okay, and this is also 533. Makeup air into 0.85% is 453. Clear? So this is wrong actually. I hope if somebody is taking screenshot, just correct this. Okay, this meter cube per hour divided by 3.6. Here, let's move forward. So now I have next question. Now 170 square meter and 3.2. Now tell me what is the answer.
Nine not 6 liters per second exhaust.
How much is that?
906, 906.
906. Okay, any other answers? How much is makeup?
770.61.
Okay, 906 and 770.
Yeah.
Okay, so basically what we did 170 into 3.2 into 6. We got 3264. 3264 is the meter cube per hour
Per hour.
divided by 3.6, which we get 906 liter per second for the extract, into 0.85 is 770 liter per second is the extract. Sorry, makeup. Right? So now it's very clear. Now I hope everybody understood how to do smoke extract calculations and smoke makeup quantity, how to find out for the corridor. Clear? Okay.
Yes.
Now let's talk about the air outlets. Basically, where do we locate these air outlets? So obviously, when people are running towards the exit from toward the staircase, right, door, so we don't need to provide, or we should not be locating the exhaust grill near the staircase, so that the people who are running towards stair door, they should not feel that smoke on their face, right? So that's why the code says we need to locate the exhaust air outlet at least 6 meters away from the stair door. So that's the first point, which is the third one. 6 meters away from the exit stair door, right? Second says the extract outlets, the supply inlets and smoke extract outlets, this should be alternative. Let's say first we have smoke extract outlet, then we have makeup inlet, then smoke extract outlet, then makeup inlet. Like that, we have to place these things alternately. Second thing, we have to locate the distance between these two grills should not be more than 15 meters. Distance between smoke extract grill and makeup grill should not be more than 15 meters. Right? And next, let's talk about the locating the grill itself. The smoke extract grill should be 1.83 meters minimum from the FFL. Okay. So if these things are confusing, let's go to. So basically, high rise and super high rise, the smoke exhaust should be, yeah. Basically, smoke exhaust should be only be at roof level. I mean, when you're exhausting smoke, you should exhaust only at roof level. You should not exhaust at intermediate levels. Let's say if you have super rise building, which is more than 90 meters, then the exhaust should always be on the roof. Okay, not to the intermediate floor. Okay. Now, if you see this picture, see here. Now, this is what we were discussing earlier in another slide regarding smoke criteria of air outlets. This picture clearly explains what is that. So this is the extract duct, which is this one, the red one. Okay. So this one is the makeup duct, the blue one. So the extract duct, if you see here, it is 15 meters from any corner. You will have next outlet. Either you have next outlet or you'll have the wall of the corridor. So here is the wall of the corridor. From the wall of the corridor is 15 meters. We have one outlet. Next 15 meters, we have inlet, alternative, extract, outlet, makeup. Again, this is makeup, extract. Do you see it's alternative? Again, this is extract, this is makeup. So all the time we have to have alternative. Clear? alternative grills. Second point is 15 meters distance to be maintained from these two, extract and makeup. Okay. Third point, if you see here, extract points shall be minimum 6 meters away from stairs. This is stair door. Okay. From here, extract grill should be always 6 meters away. Nowadays, very far actually. This is how your location of grills should be. Clear? Next. Now, how do we locate the grill itself? Now, here we understood that we need to keep the grill here 50 meters away, 6 meters away from the stair door and 50 meters away from each other. Okay, but how do we place that? Extract grill should be like this. It should be more than 1.83 from FFN. The bottom of grill should be more than 1.83 from FFN. Okay, this is the exhaust grill location. Either you can keep here, otherwise alternative what people do is, what I also do is, I keep it on the false ceiling itself. I keep it on the false ceiling, like down throw grill. So even that is more than 1.83 meters from FFN. So that is all satisfying. So either you can keep it a grill or you keep as your slot diffuser,
Slot
whatever that
diffuser.
is. Yeah, whatever that is. It's up to you. It's up to your ID design or whatever design you want to follow. But both are acceptable as long as it is 1.83 from the FFN. Clear? Next. The same logic is also for makeup outlets. Makeup outlets should always, again, alternative to each other. One makeup, one extract, like that should be there. Okay. And the velocity, the sizing of the outlets should be such that anyways, we'll come to this later. Let's remember this number. Air velocity through air supply inlets shall be lower than 5 meters per second. That means what? That means you can size the grills based on 5 meters per second. That is the logic here. Anyways, we'll also do that with the example. Okay. Okay. Let's do that now only actually. So let's say the area is 200 square meter, and the height is 3.2. So tell me how much is the flow rate required? Makeup, only makeup. Tell me how much flow rate is required for the makeup.
$906.
For 200 square meter. Are you sure?
Yeah, 906.6.
Sure. Just a moment. 200 square meter into 3.2, 640 into 6 divided by 3.6. Okay. I'm getting some other number actually. I said
You ask
200.
for makeup, no?
Oh, yeah. Good. This is what I want. Some people are attentive here. I appreciate. So now 906. So 906 liter per second is the answer, right? So let's say 906 liter per second we are distributing in the corridor. So that distribution, let's say I'll provide 2 extract outlets and 2 makeup inlets. Okay. So that means I have 2 outlets. From these 2 outlets, how much airflow I should deliver together?
906.
906. But as I have 2 outlets, so each outlet, how much do I have to deliver from each outlet now?
453 liters per second.
Divided by 2, right? Because we have 2 outlets. Divided by 2. So 453. Now this 453 liter per second, what is size I need of the outlet? Because anyways, we agreed that we have to put here, we have to put the grill here. Now see the grill, how the arrangement is. Makeup grill should be minimum 300 from the FFN, the bottom of the grill. The top of the grill should be maximum 1 meter. It should not exceed 1 meter from the FFN. 300 to 1 meter. So you have to play in this range of 700 mm. That is there for you. So now we got the answer how much? We got 453 liter per second. So this 453 liter per second, we have to put a grill here so that we can deliver 453 liter per second of air from this grill. Right? So now how do we size this? For sizing, we have simple formula, which is Q is equal to A into V. Right? Q is equal to A into V. So now what is Q? Q is flow rate. A is area. V is velocity. Now we saw here in the last slide, we saw that air velocity through supply inlet should not be more than 5 meter per second. So it should be lower than 5 meter per second. Right? So that means what? That means Q is equal to A into V. How many parameters we know here? We know Q, we know V. What is Q? Q is 453 liter per second. What is V? 5 meter per second. So now what is area? Area is equal to Q by V. Right? So now what is Q? I hope you guys are writing actually. So A is equal to Q by V.
453 liters per second.
Yeah, 453 liters per second. So let's convert that into meter cube
Meter
per
cube per
second.
second.
Liters per second converted to meter cube per second for the easy calculations. So to convert liter per second into meter cube per second, divide that by 1000.
1000.
So 453 divided by 1000 is 0.453. So 0.453 divided by 5 meter per second. So what is the answer?
0.0906.
0.09.
Let's say the after tells you to consider 300 mm for your height, which is 0.3 for the grill. Okay. So what is the width now? You will divide that area by 0.3. You will get the
0.302.
0.302. So that means 350 by 300 is your grill size. Okay. So now let us do that actually with other example. Let's say you have 200 liter per second, 200 liter per second extract. Sorry, makeup. 200 liter per second makeup is there. So now quickly do it. What is the grill size for 200 liter per second? So what I will do? I will do here. Actually, I am not. Again, somebody can help me here. Do we get a chart here? On chart has some notepad to write on this app. It's Google. Any idea? Okay. Anyways, so I'll walk you through. So I have 200 liter per second, right? So 200 liter per second. First thing what I will do is I convert it into meter cube per second. So what I will do? Divide by 1000.
Yeah.
I got 0.2 meter cube per second. This is my volume flow rate. Now, code says consider 5 meter per second for the grill sizing. So I'll divide the 0.2 divided by 5. I got 0.04. 0.04 is meter square. Because what I did, meter cube per second divided by meter per second. So second goes, meter cube goes, so meter square will remain. So 0.04 meter square is the final answer, which comes the area. Sorry, area of the grill. So the area of grill, let's say the architect says to limit the grill size to 200 mm. Right? 200 mm means 0.2 meter. So 0.04 divided by
0.2.
0.2, which will give me again 0.2.
0.2. Yeah.
So that means my grill size is 200
200
mm
by 200.
by 200 mm. Clear?
So in this case, should we consider the free area of the grill or just the total face of the grill for
Actually,
selection?
the point is here, this grill will be total grill actually, because here, whenever you say face of the grill, you will have, what do you call that?
Noise level?
Yes. Actually, good question actually. Very good question. This
Because
is the
I think during fire, there will be so much noise and alarms. So noise will not matter, correct? So
noise will not matter.
Yeah.
But what I'm thinking that the sizing, it can be done like this. First, point number one. Point number two is how much is the effective area is what, that's a good question actually, man. Usually effective area will be, the point is the sand trap is there, right? When you talk about sand trap, that's a lower actually. Okay. This is a grill. So
It's neck size now basically. What we are talking is grill neck size only.
what's that?
Grill neck size only, no, what we are
Yeah.
talking about is basically,
No,
it's
no.
not the face area or something.
No, but the point is, the effective area opening is what I'm thinking actually, because anyways, grill also will have some fins, right? Small blades.
Correct.
So that blades is what I'm thinking. Okay, let me study this, man, honestly, because I have something on my mind, which is I just want to see whether any percentage of uh, filtration, filtration, any percentage of uh, like usually what we do is in lures, we consider some kind of
Efficiency.
percentage from face to free. Okay, ideally when it comes to sand trap, the percentage will be very high. It will be almost 40%. Okay, so but grills, in the extract grills we consider close to 70-75%. But here in the grill sizing for this one, let me study this actually. Let me study this and I will pass this message to the admin. Okay, maybe admin will pass it to you once I study this properly. But a good question, man. Honestly, I didn't think of this question before. Thank you for that. Okay, let's move forward. But the concept's clear for you, right? The concept's clear. Q is going to V.
Yes, sir. Also, I
Velocity
had a
is-
question, sir. The smoke interface area, what does that mean actually?
Smoke interface
Last,
area.
like the last slide, there was one line like the height from smoke interface something. Yeah, interface. Yeah,
This
smoke
one.
layer interface. Yeah.
Yeah, basically interfaces, let's say this is 1.83. What is 1.83? 1.83 is the like height or that zone you have to create for people to evacuate. It is considered that 1.83 is the ideal height for the people to breathe, right?
Yes.
So
Yes.
at least at 1.83 height, you should maintain clear of smoke in the corridor. So that is 1.83 total corridor. Let's say the corridor width is 1.8 meter. Okay, 1.8 meter is the width of the corridor, right?
Yeah.
So that width and height. Height is how much? Again, 1.83.
Yeah.
So that 1.8 wide and 1.8 height, you have to keep that smoke. You have to keep that layer away from smoke.
Yeah.
So that's why what we do is we keep the extra grills on top of it,
Yes.
so that the smoke is extracted, because as the pressure is getting created, the smoke is going on the top.
Yeah.
And you are providing fresh air at the bottom, make up air at the bottom at 300
Yeah.
mm. That means the people who are running, they can easily breathe. So that's the concept.
So the smoke layer interface is the area below the smoke layer, which will be free for egress.
Yeah. Basically, smoke layer interface is the smoke layer. I mean, the what volume that is there on top of 1.83.
Okay.
1 you have to keep the points below that. So ideally, the DCD says maintain that range 300 mm to 1 meter.
Okay.
Yeah, so that people can breathe.
So is this 1.83 standard height and width or?
1.3 what the code says actually.
Okay.
So that is standard height means I think so, man. I don't know actually because the code says to follow 1 meter
Okay.
maximum. It should not exceed 1 meter. This 1 meter should be the top of the grill.
Okay.
Okay. Yeah. So this is how it is. If you see the typical section of the corridor, you will find the extract grill on the top, which is 1.83, and the makeup grill, you will see it here, 0.3 from the bottom of the grill and 1 meter top of the grill. Here. This is how it is. Okay, what is MSD now? MSD is the damper that you need to provide at the every branch that you take from the riser, right? So now if you see here, that the grill, the duct is coming, right? The duct is coming and you're taking branch here. So at this branch, you need to provide MSD. So why you need to provide MSD? Because in the case of fire, the MSD will open. The moment MSD opens, the fan will get activated and the fan start running. So the MSD is usually closed. Normally it will be closed. It will open only in case of fire, right? So MSD is basically, it's used to control the movement of smoke, to either it will be closed or open. But in our case, it always be closed. Only in the case of fire, it will open, right? So this MSD will be located at each branch, which you take from the riser. Okay, so this is how it is. It uses to control the movement of smoke. Mainly, it will be shut all the time to prevent the spread of smoke. So yeah, the other point is, in case of fire, again the code says, let's say you have 10 floors building. The fire will happen only in one floor, or let me say in another way. BCD, I mean the civil defense or the UAFLS tells in the code, consider the fire scenario happens only in one zone at a time. So the sizing that you're doing of the fans, you will do it the sizing only for one zone at a time only. So you'll not do for all 10 floors sizing. So the assumption is the fire will happen only one floor. So 10 floors building, let's say the corridor area 100 square meter. 15 floors building, the corridor area 100 square meter. The capacity of exhaust fan for these 2 floors, or the capacity of exhaust for this floor in these 2 buildings, those parts will be same, because the area is same, the height is same. Even though one building is 10 floors, the other building 15 floors, the exhaust capacity in that corridor will be same. Clear? Because we are doing sizing based on one floor only, as per the code. So this is how the MSD looks like. Okay, yeah, this is the picture. So now we are doing the sizing based on one zone. Let's say we have provided the MSD here. Okay, so now let's say fire happens in this floor, second floor. Okay, so second floor MSD will open. MSD will open here, MSD will open here. Okay, second floor. All the floors, MSD will be closed. Clear? That's what DCD says. DCD says your, what do you call that? Your fire happens in one floor. So all other floors, MSD will be closed. This floor, MSD will open. Clear, right? Perfect. So now I'll talk about some other aspect. We understood how much flow rate I need to provide in the floor in terms of makeup flow rate. How much I need to extract also is there, extract flow rate. So extract flow rate, whatever we get, the earlier example, we got extract flow rate answer somewhere around 906 liter per second for extract. So extract is 906 liter per second. That means the fan capacity should be 906 liter per second. Not really, actually. Why? Because there's something called as dampers. We have MSD. So MSD will have leakage, which is called as damper leakage rate. So each MSD, there are based on cases. For example, see here, we have class of MSDs, class 1, class 2, class 3, right? So what we do is we have to consider the leakage rate from each MSD. If I go here in this example, now I have MSDs here, right? I have MSD on the makeup, I have MSD on the extract. So now when the fan is running, when the fan is blowing air here, let's say fire happens second floor, the fan is transferring the air from the fan to the second floor, right? As the air is passing down, obviously air will travel here as well, right? But here we have MSD, which is closed, because when fire is in second floor, we understood that the air is getting delivered into the second floor, right? But the 9th floor, 7th floor, 6th floor, these floors, MSD is closed, but still there is small leakage happening here, right? So that leakage we need to understand. So when you size the fan, you need to size for the ACH required, the flow rate required for the floor, plus the leakages of the other floor dampers, which is, now let's say you have let's take this one, which is what we use. We use class 1 4-inch of water gauge. We use the damper leakage rating, right? So which is 8 CFM per square feet. The leakage here is 8 CFM per square feet, right? So now let's do the exercise. So the fan sizing should be 6 ACH plus damper leakage rate. Yeah. So now for the same formula, 100 square meter per 3.2. Actually, what is damper leakage rate actually?
I have one question.
What it? Yeah.
During the fire scenario, MSD will be open 100% or 50%? Because it was monitoring from the BMS also. So it will be open during the fire scenario. It will be 100% open, full open, or a little bit 50 or 80%.
Okay. Now the point is we need to provide the flow rate as per 6 ACH, right? When
Yes.
makeup means for 6 ACH, extract means 6 ACH, makeup means 0.85 of 6 ACH, right?
Right.
So your damper should open such that the entire volume that is calculated should be able to deliver.
Okay.
Okay. Which means in our case, we size it based on full capacity. Our damper will be sized on the, let's say 200 liters per second I have to give in that corridor. So a damper will be sized for 200 liters per second. So in this case, it should open 100%.
Okay.
Yeah. Okay.
Okay.
So now let's do one calculation. So 40 liters per second per square meter. This is the damper leakage rate. 48 liter per second. No, sorry. What it or how much? No, sorry, man. This is what I'm between 0.2. 0.2 liter per second. No. 40 liter per second per square meter. As per this, see here, this 8 CFM per square feet, right? The 8 CFM, if you convert it to SI units, it will come 40 liter per second per square meter, right? So now, simple question I'm giving you again. For 100 square meter area, corridor area, consider 2 dampers of extract and makeup and 10 floors project. Height is 3.2. Now tell me fan size. How much is fan size? I'm not asking corridor extract flow rate. I'm asking fan size. How much it should be?
Size means you need airflow.
Huh? What?
You consider the fan size means you need the airflow, no?
I need airflow. See here. I'll show it. You need to do this. 6 ACH plus damper leakage rate.
Okay.
Yeah, exactly. I need airflow. Yes. Any others? Okay. Now you can look at my screen actually. Now I'm considering 10 dampers. Okay. So what is damper size? 400 by 300 mm. Right. So when I'm doing 400 by 300 mm, what is the area? 0.4 into 0.3 in square meters. So it will be 0.12 square meter. Right. 0.1, 0.4 and 0.3, 0.12 square meter. So, my bad. I think 102 man. Okay, not 102. It's 40 only. Sorry, this is a mistake. 40. Okay. So again, if somebody is taking screenshot, please correct this. This is 40 liter per second per square meter. Okay. So damper leakage rate is 40 liter per second per square meter. Okay, so now 40 liter per square meter into area of the damper, which is 0.12, and how many dampers we have? 10 dampers we have, right? So 40 into 0.12 into 10 is 48 liter per second. Now what is the fan size? Fan size is how much it is? 533 liter per second plus 48. So 581 liter per second is the exhaust fan capacity. Clear?
Just one question.
Yeah.
This damper, you're considering the 10th floor. Is correct, no?
Yeah.
But the
actually
fire mode only we act 1, no?
No, that's what I'm saying. Okay, I'll explain to you. Okay, see here. We have how many floors? Let's call this is 7 floors, I think, right? 8 floors. Okay. Let's say the fire is happening here. Okay. So now this is makeup. Okay. So as I'm providing air here. There's leakage here as well. Leakage here, because air is coming from here only, right?
Yes, yes.
So leakage can happen here, no?
Okay.
If fire is happening here, the leakage can happen here as well. Let's say fire is happening here. Leakage will happen here as well, right? So that means we need to take all these dampers except this one. So this is 10 floors building. So you need to take 9 dampers because one floor is anyways the fire floor. Clear?
Okay. Yes.
That's how it is. Okay. Now here I have one mistake actually. In this diagram I have one mistake which I told you. This is correct this to 40. Right? 40 liter per square meter. One mistake I told you to correct. I have one more mistake here. Can somebody tell me? Can somebody identify that? Huh?
10. We need to mention 9. No?
Very good. 9. I mean, if it's 10 floors, 9 you have to consider 9. Yes, agreed. There's one in that case. There's third mistake also. There's one third mistake here. Tell me, can somebody identify that? This is third mistake on this screen.
Yes, the fan capacity.
Makeup fan capacity. Makeup fan capacity.
Tell me how much it is.
Just 1 minute.
I think what's the area? 100 square meter into 100 square meter, 3.2. So tell me what is the makeup fan capacity?
581.
No, makeup. How much is makeup?
Oh,
Capacity. No, what is the mistake in the first place? Did anybody understand the mistake?
Makeup also will be fully opened, you know.
Yeah, makeup is fully open, but still there is a mistake here. No, I thought somebody, the way somebody answered makeup fan, I understood. I thought you understood, man. Okay. Okay, I'll tell you now. Okay, now tell me how much is the flow rate I need for the makeup in the floor corridor? How much I need to put in the corridor? Only corridor. Tell me how much. Only in the corridor, how much I need to put makeup for 100 square meter?
453 liters per second.
453, right? Perfect. 453. So now, how much is the damper leakage we got? 48, right? Damper leakage, how much we got? 48. Let's take 11 floors project. Okay. With 11 floors project, we have 10 dampers, right? If it's 11 floors, we have 10 dampers. So with this logic, we'll get 48 liter per second, right? The damper leakage rate. So now, if you see here, what it is there here, he has taken 581 liter per second, 581, directly multiplied that in 0.85. You got how much? 493. Right? But 0.85 should multiply to what actually? You should multiply only to the corridor flow rate. The corridor flow rate, which is 100 into 3.2 into 6 divided by 3.6. This is my extract into 0.85. Makeup is 453. Clear. Now I need to add damper to 453. Right? Damper leakage will be there for the makeup fan also, right? So 453 plus 48. which gives me 501 liter per second. You should not do the 0.85 to the number including damper. This is a mistake here. You understand or no?
Yeah.
Is anybody not clear on this? This is mistake. Why? Because you are doing 0.85 to the total flow rate. This total flow rate, how you got it? 6 ACH plus damper leakage rate. You should not do like this. You should do the 0.85 only to the 6 ACH only. Damper will be as it is for the makeup as well. So 453.85 of 533 is 453 plus 48. You get 501. Clear? So with that, we come to the end of this presentation. Thank you for your time. I hope I could add value to your time, and I hope I could have add some knowledge to your experience.
Thank you so much, sir.
Thank you, Samir.
So thank you. Thank you.
Thank you.
Samir, regarding the grill size, I think we have to take 60 to 70%.
No, Bill says what I do is I'll check with the manufacturer, man, honestly. No, that's a good question. Akash asked actually, because let us check. Let us I have something to share, but I just want to get confirmation on manufacturer. Then I'll
Also, generally, the grill sizes are selected based on the catalogs. So when these are selected based on the catalogs, at that time, no need to look for the free size, free area. Okay.
Yeah.
So I believe we have selected with the formula Q equals to A into V. So at that time, we believe we need to look for the free area.
I think one more thing I'll tell you. I think the reason why I was explaining that point is because sometimes what happens, you go into client meetings, you go to meetings ID. That time we don't have catalogs handy with us, so
Yeah, of course.
you will get some idea. Okay, you can give them some idea. They'll ask us, give me one number, how much will be the grill size. Then you
Yes.
cannot. The reason why I'm explaining that point is just for you to have an idea, so that tomorrow in the meetings you can give some number to them.
Yeah, it's better to be clarified than to give any number.
Yeah, just give one number above if this is the case. We got, let's say, we got 250 by 250. Tell them 300 to 300, just to be safer side.
Yeah, sure.
There were two questions put in the chat
Okay.
from Mr. Shanawaz Ahmad saying, is asking, do the MSD connected to smoke detectors? One question is this.
MSD connected to smoke detectors. No man, MSD is not connected to smoke detectors. Basically, how this smoke gets activated is with the again, somebody who has the background of fire alarm can explain. So what I understand is fire alarm panel is the main guy who starts everything actually. Okay, who gives activation to all the all the what do you call that equipments, like whether it's smoke detector, not smoke, whether it's sounder, the fans, the sprinklers. So MSD will not be connected to smoke detector actually. I mean, all these guys will be connected to fire alarm panel. Rather.
Yeah, first there will be some time delay, and if it is not acknowledged, then it will go to the fire mode.
Yes.
All right. Any more questions? If you can ask, you can unmute yourself and ask directly with the speaker.
Hello.
Yeah.
Yes, Mr. Adil.
Hello, this is Adil Sheikh from Mumbai. I had just one question.
Okay.
So I wanted to ask you what will be the material of the grills which we are going to use in corridor ventilation, smoke ventilation or exhaust.
Material of the grill. Material grill.
Has to be fire retardant, right?
Huh? What is it?
No, usually it will be the same grill.
But no. The normal grills are not fire rated. I think we must have fire rated grills.
Yes, for sure. Yes.
Normal AC grills, normal grills are not fire rated. They will get damaged in the fire condition.
Yes,
or
yes.
they maybe melt out.
Mhm. Actually,
So is there any
rating,
specific
rating in my
fire
opinion,
rating there?
I think the rating in my opinion, I think the same rating, man. Again, 2 hours for what 400 degrees.
Is there any standard that's mentioned in this kind of bills?
No, and the
Is there
standard
any
for the
standard
grills,
mentioning this type
we
of
don't have
things? Or,
grills for grills. We don't have any standards. For the fans only we have. So what we do is we follow the same rating actually for the grills as well.
but in our tenders or BOQ, how do we mention? How do we
It should be
specify
fire rated. It
regarding
should
this?
be fire rated grills.
But there should be some material specification for this, no?
Material specification,
Like
that will check.
like we give aluminum extruded or something like that. We have that kind of specification written in our BOQs or tenders maybe. Of course, we have to give them specifications, or else how the contractors or the clients are going to execute this on the site.
Yeah, that's a good. Again, specifications will be there actually, but specifications, we need to mention like you said. We need to mention, otherwise there will be price difference, right?
Yeah, that will be price difference.
Yeah, I agree. But again, the
So
material.
can you please let me know that what material or what standard can we follow? What is normally followed in the standard? What is the industry standard for that?
Okay, we can check that actually.
Hi, Assalamu alaikum. Thank you, Mr. Samir, for a beautiful presentation on this topic. I have small question regarding the material of construction for ducting. It is GI again.
Yeah.
As you told, 400 degree for 2 hours. Like, do we specify any thickness, like gauges? Like this is the gauge to be standardized, and this duct should be UL listed in particular, or it can be DCD approved but cannot be UL listed. That product also we can look into. 2 questions, please.
Actually, this question, man, honestly, specifications have to check actually. Okay. So what I understand is for sure it is GI duct. Okay. The thickness of the duct, that I have to check, because the thickness of the duct depends on the this one, right?
Sizes. That happens usually in our HVAC construction. The thickness of the duct depends on the pressure classifications and
the rating also, I think, right?
yeah. Yes. But in fire, like, is it any standardized that it should be of 1.2 mm thick, or like again it can vary based on the pressure classification and the airflows and all. This was one, and all the ducts need to be UL listed, or can be without UL listed but DCD approved. That this is there are some products, there are some manufacturers in the market who are not giving UL listing, not accordance with UL listing and ANSI one code is there, but they are already DCD approved. These kind of ducts also can be manufacturers also can be proceed.
I believe, in my opinion, again, I have to check actually. So UL listed should be there, man, in my opinion.
In most of the construction project, the GI duct should be UL listed. Mostly in our construction projects, I already seen that. But most of they are following a specification. There's some local authority, civil defense, some NFPA specifications. But most of the GI duct should be UL listed. Fan, duct, all the fire related systems should be UL listed.
For smoke also, smoke ventilation basically.
Yes. Every fire alarm materials should be UL listed. It is mandatory, but it depends on the specifications, or because NFPA is already says that the fire related material should be the UL listed.
Yeah, because end of the day, it is the inspection carrying out authorities, civil defense, like DCD in Dubai. When I'm speaking,
yes.
But they have the manufacturer, the GI duct manufacturer. He has already the DCD approval. He is attaching the DCD approval and is telling that we are already in compliance, giving the product, giving the ducts in compliance with DCD, but he's not giving the UL conformance. But how come DCD has approved that? Maybe But yes, of course, the project specification will have precedence. We have specified in our project specifications that
If the vendors they are telling that if they are telling that material is complying with the DC, then it's okay. It depends on the local authority approval. But most of the cases I seen that in the Qatars, the materials all should be UL listed. They civil defense they are asking during these inspections, and in the consultant
This is
also they are checking the material itself should be UL listed.
correct. Exactly.
All right. Thank you for your precious, valuable insights. I'd like to know if anyone still wants to ask any question, please.
When will be the next seminar?
Yeah, this will be in the next month, of course. Absolutely. We'll announce, hopefully, in this week, we'll announce the next webinar. This is arranged by ASHRAE. So it will be related to something mechanical. I would be appreciated. I will be, sharing this announcement soon in our community groups and platforms. Thank you for reminding that, Mr. Mohsin. Mr. Samir, any last message, concluding message? Then we will close this.
No, thank you. But we will continue with next seminar. We will get upgraded with fire alarms related.
Yeah, my last message is when will I get payment?
You have to claim the
Okay, no
invoice.
problem. No problem. Okay, thank you, sir.
Mr. Samir.
Okay,
Thank you.
I had a good time. Thank you for everyone. Thanks all for joining. Honestly, I believe we need to educate each other. We need to share knowledge with each other so that
Yes.
it's a good initiative, honestly, by UAMP engineers. I believe as we interact more, we tend to ask more questions. We tend to understand more concepts in clarity, right? I think the more clarity you have, the more confidence you get. That's my understanding of engineering, right? So that's why whenever I attend these seminars or give presentations, whenever I get questions, that's when I start getting more into so I think that's one thing which I really enjoyed in today's seminar. Thank you for everyone. Thank you everyone who are participated, have engaged actively. Again, I want to lastly thank UAE engineers for inviting me and sharing and giving me an opportunity to interact with your members. Thank you again.
It was an honor, Mr. Samir. Thank you for that insightful session. Just I'd like to remind everyone regarding our professional ecosystem, how we have made. The QR codes already are on your screen. You can actively join and participate. There are other things which, if I discuss now, it will take a long time. Just go to the website, explore the resources there, the code extracts, the study materials, what we have uploaded there, and the challenges what we are already being sharing on the LinkedIn profile. So thank you all again for your time, and inshallah we will soon be sharing you the certifications, whoever has been attending and attended this session. Thank you once again and have a great day ahead. Assalamu alaikum.
Thank you.
Thank you.
Thank you very much.